from Monday. Okay, here's what's going on. When these lines are parallel, a lot of cool things happen with these angles. So what I want you to do is go to Schoology, and you're going to try to kind of discover these on your own. So I want you to go to Schoology.
This is my homework.
I want you to click the Unit 3 folder. And then I want you to click 3.2 Exploration. It should pull up a screen like this, just like in your Schoology window.
I don't want to explore.
We're going to explore. And it's not bad. Raise your hand once you get here. So Schoology, Unit 3, 3.2 Exploration is where you're going.
TBH is not working.
Schoology ain't working.
TBH, the charger isn't
I
working.
think I already graded this one, but I'll
Okay.
I think I graded it back to we'll see it. So everyone should be at this screen. Jordan, nothing. Yeah, there you go. Click
Yeah,
that.
shut up, bro.
Perfect. Good.
Yeah, do so
Before we
bad.
get back
Do
to your
so
will.
bad.
No, you are not. Are you good, Isaac?
Bro, you good,
No,
yeah.
Unit
Click
3.
continue, Kayla. Good over there. Okay.
I'm not.
Once you're here, listen.
know where I'm
Yeah.
going.
Yeah.
Unit
It's
three.
black.
So
Oh,
it's not
no,
on.
you're right. Yeah. Unit 3.
Nah, the charger broken. Your charger's broke.
I think your computer.
Jordan, you still need it.
Huh?
Where
I
are
think
you?
your computer's.
You got it,
Are
Robbie.
you on there
Spit it out.
right?
Nah.
Perfect.
Oh, there it goes.
Okay.
Your charger just is really
When you are
slow.
on this screen,
This.
3.2 Exploration.
The-
Once you're on this screen, click continue without signing in.
Shut up.
Put your name in. And click start. Do not touch anything yet. Your screen should look like this.
Wait.
If you notice, it also looks like this picture in your notes. Here's what I want you to do. First step, click the More button. It should drop down a few other options. Scroll down to the Measure and click Angle. So we are clicking this button right here, Measure Angle. Click it and it should be highlighted. Your job is going to be to measure all of our 8 special angles, and here's how you do it. For example, this angle right here in the top right, what's the name of this angle? Angle A, what would it be if it was 3 letters?
BAD.
BAD. To measure this angle, I press those letters. I press B in the order that I read them in. So BAD. And it'll pop up a measure. This one says 120. You just can't see the 1. I want you to do that for all 8 of these. Okay, by tracing out the angle, pressing the 3 points, and then I want you to write down your measures on your paper. And that's it. When you're done with those, we'll talk about it. But I want you to measure all 8 of those angles, okay? So I'll give you a few minutes to do that.
My paper just.
Get Will car. I will move you front and center. I have an extra seat at my desk if we can't stay on track.
Let's take a break.
Got
Got it, Will.
At a point like over here, you'll have to trace out the angle. Well, like D-A-D. But yeah, there's the angle. So again, guys, to trace out an angle, let's look at this one down here. What's the name of this angle in the bottom left?
CAG.
FCH.
FCH. So when I measure it, I click FCH, and it measures it for me. Okay? So do that for every angle.
Where do I write this?
On the paper, in your notes. No, you're not on the right page. Right here, it matches perfectly. You have to
I'm also
measure
really
it
Oh,
out.
stupid Robbie. Oh.
And
You're so dumb. I'm already done.
make sure that angle word is highlighted in blue.
I don't know who you're calling.
You can't measure it without it.
I'm already done.
There's an undo button in the top left.
What's your grade in this class?
Right here.
I don't know.
That's the same picture.
I bet you
Just
don't
write
have
it
the
out.
AGs.
So like this one's 60, I just want you to write a 60
I
down.
got an A in this
So our
class, buddy.
charter.
8 total. So now
I have
you
an
do
A
the
in this
inside. You do
class.
the outside, do the inside. Beautiful.
Hey,
Looks really good, Shay. Jordan, you're not even on the right thing. Again, there's a seat right here on my desk if we can't stay on track.
it's loaded.
No, it's not.
Yes, it is.
See right next to the candy bucket.
No, like the BAG.
Jordan's name.
You don't type it, so put more. measure angle.
Jordan, what's your
and then
middle
you
name?
press the ones that you
Ray.
press in order. So B, then
Like this name.
and then boom, it pops up.
Ray?
Okay?
Yeah.
Get to work, get to work.
You know what? You might be black.
Okay, so then you raise your hand and ask a question.
It's my biggest nightmare.
Says angle. How would I met? What's the name of this angle over here?
I think you're my biggest nightmare, buddy.
Uh-huh.
I think I'm with you.
Not DAC, that's straight. What about like this guy right here?
Oh, it's a bug. Where?
D-A-E. I'm
scared.
Run!
A,
It's a stinker.
E, and then I give you
Don't
my
tell
thumb.
it then.
So I want you to do that for all 8. Isaac Tracy, what are you doing?
Stink
There's a
bug.
bug.
Oh, get it.
Throw it out the window.
Kill it.
Don't push it. Perfect drop. Good.
Ah.
Okay. Let's talk about these together.
No, do not have.
So, pull out your notes and fill this out with me. Chromebooks can be closed as long as you put it on your notes. Close your Chromebooks.
Did I keep on my notes? I can fill out.
And pull
Where
up.
does this stink come from?
The
The
stink.
front or the back?
The bug.
I have no clue. Is it actually?
Just throw it out the window. You gotta open the window.
Wait, is it on page 7?
Page 8 is where we're at right now.
Yeah, just throw it out the
Ah,
window.
yeah.
Yeah, open the window.
Kill it! Kill it!
You probably should have opened the window before we grabbed the bug, but that works as well. Is it out?
Yeah.
Thank you, Isaac. Would you like some candy for your
I would love
service?
some
Thank you.
I think it's 2 pieces of candy today.
Okay. So, someone tell me, what do we get for angle DAE here? Go ahead.
Yeah.
60. What about the one next to it, DAB? 120, okay. What about BAC? 60. What about EAC? 120, okay. What about FCA? 60. ACG?
120.
120. FCH? 120. GCH? 60. Does anyone see a pattern? There's a lot of angles that are the same, right? Let's look, and a lot of angles that add to 180, even better. I love those two things. So here's what's going on. When these lines are parallel, and only when these lines are parallel, a lot of those angle relationships we talked about end up being congruent or supplementary. For example, let's look at corresponding angles. And I want you to write this down. Let's look at this angle right here. It's in the top left. Remember, corresponding means same spot. So its corresponding angle is down here, top left of the other line. What do they have in common? What's their measure? Same, different? What do we think? It's the same measure. And angles that have the same measure, what do we call them? Congruent. So corresponding angles, when your lines are parallel, are congruent. They're both 60. Let's look at alternate interior angles. Here's one interior angle. Alternate, Jordan Heights, alternate across the transversal, interior in between the two lines. So that's this one right here. The purple ones are alternate interior. Are those ones congruent or something else? Congruent. What about alternate exterior? Congruent. That's like they use 120s right here. Alternate exterior. They're congruent. So when we have two parallel lines, corresponding angles, alternate interior and exterior angles are congruent. Let's look at consecutive. What angle measure is consecutive to this 60 right here? Consecutive means same side of the transversal, so something on the right. And let's do interior, inside the two lines. What angle would that be? Yeah, it's the 120 degree right here. Those are consecutive interior, same side in between. And they are, what's 60 plus 120? What does that add to? 180. And what do we call two angles that add to 180? Supplementary. So consecutive angles, either interior or exterior, it doesn't matter. They are supplementary. So these are the kind of angle relationships that we're going to talk about today. Anytime these two lines are parallel, we have a bunch of congruent angles and we have a bunch of supplementary angles. And we can basically fill out all 8 of our angles from only knowing one. Okay? So that kind of leads us into these 4 theorems that we're going to talk about. A lot of these are worded nearly identical. They just have like one word that has changed. Jordan, close your Chromebook for me. First one, corresponding angles postulate. Again, these theorems only work when the lines are parallel. If these 2 lines are not parallel, we cannot say anything about the angles. We don't know anything. If they're parallel, we know a bunch of stuff. And here's what we know. If they're parallel, then corresponding angles are congruent, like we found in the exploration. So what angle number is congruent to angle 1? What's its corresponding angle? Corresponding, 5. It is congruent to angle 4, but not because corresponding, because vertical. But angle 1 and angle 5 are corresponding. What about angle 2? What's its corresponding angle? So angle 2 is congruent to angle 6 because they're corresponding and on parallel lines. What about angle 3? 7. So angle 3 is congruent to angle 7 because they are corresponding angles on 2 parallel lines. And then what's our last pair? 4 and 8. So angle 4 is congruent to angle 8. So just from this one theorem, we have 4 sets of congruent angles. Yep. Corresponding angles are congruent if the lines are parallel. Again, the lines have to be parallel. If we did not have this, or if we did not have 2 little arrows on our parallel lines, that's how we show parallelism. If we don't have that, or we're not told the lines are parallel, we can't do anything. We stop, we don't know anything about the angles. But if they're parallel, we know everything that we're going to talk about today. Okay? So the next theorem, alternate interior angles theorem. Again, if we have 2 parallel lines cut by a transversal, then the alternate interior angles are also congruent. So angle 3 here is an interior angle. What's its alternate interior angle pair? 6. So angle 3 is congruent to angle 6. What's my other pair? 4 and 5. So angle 4 is congruent to angle 5. Whatever noise is happening, turn it off. And close your Chromebook. Okay, so alternate interior angles are congruent if the lines are parallel. Alternate exterior angles are also congruent if the lines are parallel. So what's alternate exterior for angle 1?
8.
Angle 8. And then what about angle 2? 7. So, corresponding or any of your alternates are congruent. The only weird one is consecutive. Consecutive interior angles or exterior are not congruent, they are supplementary. This is the weird one. This is the one that you'll have to memorize. Okay, perfect. So 1 and 7, yeah, those are exterior. Let's just look at interior. 3 and 5. And 4 and 6. So what this theorem tells us, yeah, measure of angle 3 plus measure of angle 5 is 180. And measure of angle 4 plus measure of angle 6 is 180. They're supplementary.
Too easy.
So anytime we see a picture like this and we have parallel lines, we can go crazy and know all of our angle measures. Okay? Can you close your Chromebook for me? Questions on the theorems?
No.
Measure of angle 3 plus measure of angle 5 is 180. 4 and 6 is
Do
180.
you have to write it like that on the test?
And this is how we're going to set up our equations. So, for example, if I said angle 3 was 100 degrees, you would say 100 plus the measure of angle 5 is 180. So angle 5 has to be, if 3 is 100, angle 5 has to be 80. Okay? So we're not necessarily going to write these out explicitly, but we're going to use them to solve for angles and variables.
Oh, okay.
Okay. But again, the only weird one, and like put a star next to it, do whatever. The only weird one is the consecutive. That's the only one that's supplementary. Or the only like nice, pretty relationship that's supplementary. The rest are congruent. Okay? And tomorrow we're going to talk about the converse of all of these theorems, where we can actually use these angles being congruent to prove the lines are parallel. So this relationship does work both ways, but we'll talk about it on Friday. I'm also not here on Friday, just a reminder.
So how are we going to talk about it?
You're going to watch a video.
Bro, but that video not gonna help.
It is going to help because it's exactly what's going to be up here either way. What's up, Isaac?
Is the consecutive interior, is that the same side one?
Same side, yes. Yeah, so another reminder, I'm going to use the word consecutive, but anytime you see consecutive, it also is the same as same side. Caden, turn around. Will, stop messing with him. Yeah, stop. Either way, you two, stop. Consecutive means same side. So on your test, it'll say consecutive. I just made the test. I use this word on the test. But I'll put up on the front board like consecutive equals same side. So you memorize whichever one you want, and you'll know that it's the same either way. Okay? Okay, let's do some examples. It says the measures of 3 of these numbered angles is 120. We have to figure out which ones and why.
5.
Hold on. Okay, I agree. 5. Why 5?
'Cause
Here's 5. What are those two angles called? Not complementary. What's their special angle relationship? Corresponding. So angle 5, since it's a corresponding angle, it has to be congruent because the lines are parallel. So its measure is also 120.
Oh.
And if 5 is 120, hold on. 4 has to be 120 because what are those called?
They're alternate.
Alternate interior. That's one option, but how can we stop interrupting. How can we relate angle 4 and that 120 degrees without going through angle 5 first? Vertical. Perfect. So angle 4 is also 120 because of vertical angles. And just remember, vertical angles are always congruent. We don't need parallel lines. We don't need a transversal. We just need that X shape. And then our last one, Reagan, go ahead. Angle 8, what do we call angle 120 and 8? Alternate exterior. And again, I kind of abbreviate alternate X. So again, what we did here is we said, okay, here's the 120. I know its corresponding angle is congruent. I know its vertical angle is congruent. And I know its alternate exterior angle is congruent. Okay? We only did that because of these parallel line symbols. We could not have done that without those. Okay? Let's do another one. It says, tell whether the angles are congruent or not congruent. First step, do we have parallel lines?
Yeah.
Good. Okay, so we have parallel lines, so we are good to go in using all of these theorems about congruence. Let's look at angle 1 and angle 8. What's their relationship? But what's the name?
Alternate.
Alternate?
X.
Exterior or interior?
Exterior.
Exterior. And since our lines are parallel and they are alternate exterior angles, are they congruent or supplementary? Congruent. Boom. Also, this example 2 and 3 here, these are very, very similar to ones on your test. I would put a star on it. You probably want an example like this on your cheat sheet, which I also have your cheat sheets ready to go. You can grab those whenever, okay? But you'll for sure get them on Monday. Okay?
Wait, the test is on,
Your test is on Wednesday. It's a quick turnaround, I know. The next unit's a little
How
longer,
many
so
questions is the test, you know?
I can tell you in a second when I look at it.
I'm ready to get over.
Okay, let's keep going.
I'm ready to get a 42.
Let's look at angle 4 and angle 2. This one's weird. I would ask you, interior or exterior, and what would you tell me? Like neither, right? Like 2's kind of inside or outside and 4's kind of inside. So, and they're on the same line. So this actually has nothing to do with our parallel lines cut by a transversal because they're both on the same line. What if I went like this and I said these two angles make a straight line?
I would say
Yes.
liar.
Say it.
Linear pair.
Linear pair. They make a straight line. They are a linear pair. We cannot forget those other angular relationships we talked about in Unit 1. They're coming into play today as well.
So that means
So if they're a linear pair, by the linear pair postulate, they are?
180.
They add to 180. They're supplementary.
I think math's a lie.
What?
But again, just a reminder, we still have linear pairs and we still have vertical angles. And they'll happen, we'll see them a lot in these things. Hold on. So let's just fill out some quick numbers here. Let's look at angle 8. What does angle 8 have to be if it's also a linear pair with 120? 60. So what's angle 1? 60, because we already said they were congruent. What's angle 2 then? 120, linear pair. So what's angle 4? 60, linear pair with that 120. So kind of see how even though we have one number, we can get the rest of them. Let's keep filling out the rest. What's angle 3? 120. What's angle 5? 60. What's angle 7? 120. Perfect. That pattern is the same, just with different numbers. These ones match and these ones match, and then the other two. Let's look at angle 3 and angle 7. Obviously, they're congruent because we just labeled them both 120. But what's their relationship? Corresponding. They're both in the bottom left. So that one's corresponding. And corresponding angles with parallel lines are congruent.
Everyone knows that.
I want you guys to, we can fill out the first part together. 3 and 4, are they supplementary or congruent? Supplementary, okay. What about 2 and 7? Congruent. What about 3 and 8? Not congruent. I want you guys to try to figure out the relationship between 3 and 4 and 2 and 7. 3 and 8 doesn't have a cool relationship besides that they're supplementary. But I want you to figure out from that poster, are they alternate interior, exterior, corresponding, consecutive? I want you to write their relationship right there. And we'll reconvene in a second to check. Well, you know it, of course.
Does he have a cheat sheet?
Mm-hmm.
That's cheap.
Wait, isn't the detention room this?
Huh?
Isn't the detention room this?
No, they moved it. It's now, the detention room is upstairs.
Dang. Isn't it Mr. Sun?
Yes.
His room?
Yes, Mr.
Oh, it's the same teacher, but just different.
Yeah, they just don't do it in here anymore. Okay. Angle 3 and 4. What's their relationship?
Linear pair.
Linear pair. They make a straight line. Do we all see that? If I kind of cover up 1 and 2, I get a straight line here with 3 and 4. That's a linear pair. So we could have done that in Unit 1. Okay? Hopefully. What about 2 and 7? Alternate because they're across the transversal. Exterior because they're outside the two parallel lines. Perfect. Perfect. So, again, we only use these theorems if the lines are parallel. If I gave you this, clearly those lines are not parallel. Here's a transversal. I could not say that those two pink ones are congruent. They would not be congruent. Okay? So we're only doing this if the lines are parallel. We're only doing this when? If the lines are parallel. I promise you on your test, someone's going to mess that up. They'll have two parallel lines and it'll ask you, are these two angles congruent? One of you will say yes. Don't say yes. Only when the lines are parallel can we do all these fun things. Isaac.
Is there a study guide for the test?
Yeah, you'll get a review on Monday. I have it printed if you want it early. Okay? Same thing with your cheat sheet and review. You'll all get it on Monday, but I have it early if we need it. And I won't be here on Friday, so if you want to grab it on Friday, just grab it today. Because the sub, I don't want her to have to deal with that. Okay. So, there will be a question like number 2 on your test. There will for sure be at least 2 of these on your test with some algebra. Okay? But we do the same thing. First step for this very first one on the left. Are the lines parallel?
Yes.
Yes. So then we have the go-ahead to use all of these theorems.
I know it.
Hold on. First thing, let's figure out their relationship. How do these two angles relate?
Alternate.
Alternate exterior. Very good. So those are alternate exterior, and alternate exterior angles with parallel lines are what? Congruent. Perfect. And if we remember, if two angles are congruent, we can set their measures equal. Perfect. Remember, you see congruent, you think equal to. Okay? So 72 is equal to 7x plus 9. I solve like normal.
Algebra.
7x.
Algebra, what's my first step?
-9.
Minus 9. What's 72 minus 9?
63.
Very nice. 63. Thank you for the restraint.
67.
So 63 is equal to 7x.
9.
Divide.
Stop cheating.
I'm not.
Divide by 7. 63 divided by 7. 9. I've taught you guys the 9's trick, yes?
No.
Yeah.
I feel like I have. Okay. Like, you put down your 7th finger, you get 60 for your 10th place, 3 for your 1s.
What?
Ah, 9's trick. You might not have been here.
I did not know that.
I think you were suspended or something.
So that's that one. Alternate exterior, x equals 9. If, hold on, if it said what's the measure of this angle, what would you tell me? Do we need to plug x back in?
Yeah.
No.
No.
What's the measure of this angle if it's the same as this one?
72.
72. We don't have to plug anything back in. We know it has to be 72. Let's look at the next one. First step, are the lines parallel?
Yes.
Yes. So we can use all of these theorems. Inside or outside? Inside, so something interior. Opposite sides or same side? Same side. What's the other word for same side? Consecutive. So consecutive or same side, either works. I think Big Ideas uses both. I think it just depends on the assignment. So just be aware they're the same. Consecutive interior angles with parallel lines. Someone besides Jordan, they are what? They're the only weird one. Supplementary. They're the weird one. Supplementary. So that means their measures add to 180. So here's what your equation setup is going to look like for any supplementary angles. A measure plus a measure equals 180. What should go in this first spot?
140.
Sure, 140. What goes in the second spot?
8x.
8x.
Subtract 140.
Yep. And then we're just solving algebra. Subtract 140. Isaac, put it away. 8x is equal to
20.
40.
40. 180. Jordan, turn around. 180 minus 40 is 40.
40 equals 8x.
Bye-bye.
Divide by 8, we get x is equal to 5. 40 divided by 8 is 5. Very good.
We're done.
So again, we start with are the lines parallel? Then we get the relationship. Then we get how the measures interact. And then we do our equation. 4 steps. You have to check that the lines are parallel first. Okay? Let's go down to here. First step, are the lines parallel? Parallel because of those red angles. Or those red arrows.
Oh, the red angles are making parallel? I thought it was just the arrows on the end.
These arrows make it parallel. The arrows on the end just make it a line. So you have to have like that extra little arrow on the actual line.
Ooh.
It's reflected.
So, inside or outside?
Alternate.
Interior, alternate or I can't. Alternate or consecutive? Alternate. I was trying to write and talk at the same time and it was not a good idea. Okay, alternate interior.
I forgot.
Thank you.
Send them away.
Alternate interior angles.
Congruent.
They're congruent if your lines are parallel. They're always congruent unless they're consecutive. So just remember, everything's congruent except consecutive is supplementary. Okay. So they're congruent, so we set their measures what to each other? Equal. So 17x minus 4 is equal to,
13x plus 12.
exactly, 13x plus 12.
So, 4.
How do I solve?
Plus 4.
Yeah, pick a side for your variables to go on. Which side should I put them on?
Subtract
The left
13.
side.
Let's put them on the left so they stay positive. Let me subtract 13x.
So it'd be 4x.
I get 4x minus 4 on the right. And I moved all my x's to the left, so I'm going to move all my numbers to the right.
So add 4.
Add 4. What's 12 plus 4?
4x equals 16.
16.
Divide by 4. That'd be
Divide by 4, we get x is equal to 4. Again, take your time with the algebra. Ask me questions if you're stuck on a test, because I'm not teaching you algebra, I'm teaching you geometry. So don't let the algebra hurt you, okay? If we don't know the algebra, we can work with that, but we got to know the geometry, okay? Last one, before we kind of go backwards, you'll see in a second. But last one.
Parallel.
Parallel lines, yes, good. So we can use all of these theorems and set things equal. Inside or outside? Neither. So we're hoping that it's corresponding. Are these ones corresponding?
Yes.
Yep, they're both in the bottom right. In corresponding angles, if the lines are parallel, they are congruent.
Your what? Your words?
So I set their measures equal. 6x plus 4 is equal to 142. Subtract 4. 6x is equal to, very nice, 138. We take out a calculator.
Big 2, 3.
Yeah, we pull out a calculator. We divide 138 by 6. We get 23. Also, just an FYI, you'll have one side of a cheat sheet to work with, but also that poster will be up for the entire test. And I'll even move it to the front so it's easier to see. So you'll already have a kind of big picture besides your cheat sheet. Don't put your notes away. Let's go back up here real quick. Let's do the warm-up that I skipped because I wanted to make sure we had enough time. Do we remember parallel lines? Listen. 25. Or 35? 35.
I wish it was 25.
Okay.
Get out early.
I know. Listen, from Algebra 1, parallel lines, what was special about their slope? Do we remember?
Parallel lines, they were 0.
That's horizontal. What about this? The slope is what? Yeah, it's the same. If we remember, parallel lines have the same slope. Well, you do need to know this for Algebra 2. That's kind of why I'm refreshing you. And perpendicular lines, they have opposite reciprocal slope. So write that down, and I'll tell you what it means in a second. Perpendicular, sorry.
I remember what that.
So perpendicular lines have opposite reciprocal slope. What that means is if one of my slopes is 2, the opposite reciprocal is the different sign, so positive would become negative, and we flip our fraction. So what is on the bottom of this denominator right now? What's on the bottom of this fraction? There's a 1. So if I flip it, aka the reciprocal, I get 1/2. And if I include the opposite, aka opposite sign, I put a negative. So that's what perpendicular slopes look like. You flip your fraction, you change your sign. So let's kind of use slopes a little bit to graph some parallel lines. First one, it says graph a line that intercepts the y-axis at 3. Let's pause for a second. If it intercepts the y-axis at 3, what ordered pair do I have? When y is 3, what is x? 0. That's my y-intercept. 0, 3. So I plot that point. And then I look at my slope. My slope is negative 2/3. So my line should be kind of pointed down.
Going down by 2.
Perfect. Remember, it's rise over run. So we're rising by negative 2, and we're running 3. So down 2, to the right 3. Or if we wanted to go the other way, up 2, to the left 3. 3 points is all we need for a line. Connect your points with a straight line. And put some arrows on the end.
Whoa.
Easy. So that's our first line. What's up?
Testy.
Yeah, they're just really hard to see. They're really
Make
thick.
me.
Just
We'll make you side out.
Oh,
Oh,
make me.
you
Sorry,
really
that one.
really can't
I
see
love
them.
that.
Just kind of estimate. These little slashes are all the numbers,
Both
so
of
act like those are your
both
lines.
maps.
Yeah, sorry that graph printed terribly. I don't know why. But that's our first line.
Oh, there's 2 F's.
Do we remember slope-intercept form?
Yeah.
What's slope-intercept form?
NX
Y equals,
NX plus B.
yeah, y equals mx plus b. So I could write the equation of this line in slope-intercept form. What's m? Is it my slope? Is it my y-intercept? Is it something else?
Slope.
It's my slope. So negative 2/3 x. And what's b?
The y-intercept.
The y-intercept. So b is positive 3. So these are just algebra refreshers, but we're talking about it because we're going to draw another line that's parallel to it. Okay? So number 2 says we're going to graph a line that intercepts the y-axis at negative 2. So now we're graphing the point 0, negative 2. Right there. And it says this line is parallel to the first line that we drew. So if it's parallel, what's my slope of this second line? The same, yeah. So m, my slope, is negative 2/3. And this also kind of relates back to our theorem. Through this point, that's not on this line, there's only one line that we can draw that's parallel to this line. We're about to draw it, and it's the only one we could draw. So we draw it by using the same slope. Down 2 to the right 3. Or up 2 to the left 3. And then we connect our dots, our points. And if I wanted to write an equation for this line, y is equal to negative 2/3 x. What goes on the end?
-2.
Minus 2. Very good. Minus 2. And then last thing real quick, if I wanted to visually show that these lines are parallel, what would I add on my graph?
Red arrows.
Yeah, usually they're red, but whatever arrows like on your line, they'll be up here, down here, in the middle, it doesn't matter. But 2 little matching arrows, one on each line. So again, we talked about all of those angle relationships on Monday, and today we talked about how their measures compare when the lines are parallel. So your job for the last 30 minutes, big ideas homework, self-check, part 1. You could probably start your second self-check, or at least look at it. And if you finish all of those, you can either, 1, study the Quizlet, because I would listen real quick. The first 5 questions of your test are word-for-word vocabulary, fill in the blank from the Quizlet. Okay? So study the Quizlet, or start your cheat sheet, or start your review if all of your homework is caught up. Okay? Real quick about Friday, I will not be here.